Hi guys, so we're going to look at some simultaneous equations. Now I've picked some that are either weird in the way that they're worded or ones that are created from shapes. So I'm going to do you 4 examples to begin with, and then you've got a set of 10 questions to have a go at that are all similarly weirdly created. So this is the one off last lesson's work that a lot of people either left blank or didn't know how to answer. Some guessed the numbers just to make the equation work. But at the end of the day, you won't have the answers in the exam. So when we're solving these sorts of questions, you've got a rectangle where this side is the same length as this side, and the top is the same as the bottom. So I can basically say that this is equal to this and this is equal to this. So if I write left and right, I can say x minus y has to be equal to 3y minus 2. And then top and bottom, I can say x plus y has to be equal to 4y plus 1. So first thing I'm going to do is just rearrange both equations. So all the x's and y's are on the left hand side, any numbers left over are on the right. So for this one, I'm going to subtract 3y from both sides. I end up with x minus 4y equals minus 2. I've got one of my simultaneous equations. On this one, I'm going to subtract 4y from both sides. So I end up with x minus 3y equals 1. So I've now got a pair of very simple simultaneous equations. So x minus 3y equals 1 and x minus 4y equals minus 2. So since the x's are the same and they're both positive, I'm just going to subtract them. X take away x is 0, minus 3y take away minus 4y means that I'm adding it on. So I get y equals, and 1 add 2 gives me 3. Once I've got my y value, I can substitute that back into any one of my equations. I'm just going to use this one. So I get x minus, and since y is 3, 3y would be 9, equals 1. So if I add 9 to both sides, I get x equals 10. Now there was in last lesson's work a little bit more to this question. It actually asked for the area of this shape. So for this one, I'm just going to go through that. So x plus y, well, you've got 10 plus 3 is 13. X minus y is 10 subtract 3 is 7, and the area worked out as 13 times 7, which is where I got 91, and assuming everything was measured in centimetres, it would be centimetres squared. Okay, but that's our first example. If I look at the second one, they can also tie perimeters of shapes and angles inside shapes all in to create simultaneous equations. So what I've got is these 3 lines tell me that this is an equilateral triangle, which means these 3 sides have to be exactly the same. So I've got 2x plus y 3 times, so I'm just going to put a 3 in front, has to equal, and it tells you the perimeter is 300. Okay, so I've got 6x plus 3y equals 300. I've got one of my equations. Okay, second one I've got is that x plus y. Now, because this is an equilateral triangle, I can just do x plus y equals 60, because I know in an equilateral triangle this angle has to be 60 degrees. If it wasn't an equilateral, what you could do is this one plus this one plus this one has to equal 180. Okay, and since they're all the same, I'd end up with 3x plus 3y equals 180. Whichever way you do it is absolutely fine. So as I said, because I know this is an equilateral triangle and this angle is 60 degrees, I know that that has to equal 60. So I've got my 2 equations. First thing I need to do is make one of them the same. So I'm going to times this one by 3. So I've got 6x plus 3y equals 300. And this one, if I times by 3, I get 3x add 3y equals 180. Then I can just subtract them. 6x take away 3x leaves me 3x. These are going to cancel each other out. 300 take away 180 is going to leave me with 120. And if I divide by 3, I get x has to equal 40. I can then substitute that back into any one of my equations. I'm obviously going to pick this one since it's the simplest one out of all of them. If x is 40, I get 40 plus y equals 60. So y must be 20. And that's it. I've got my values. Right, what you can get is worded questions. Now, the typical worded questions you get is someone drove route X so many times, route Y so many times, or you get so many adult tickets plus so many child tickets. Okay, this is just a bit more of an unusual one. You've got a sum of two numbers is 21. Now, sometimes they can give you the letters. We're just going to use X and Y as our two letters. So I know the sum means to add them up. So I know X plus Y has to be 21. And the difference is 7. So I know X minus Y has to be 7. It doesn't matter which way around you pick your letters, just as long as you're consistent all the way through. That means if I write one above the other, to get the x's to cancel out, I'm going to subtract. So x subtract x is 0. Y minus minus y means I'm adding it on, so I'd get 2y. 21 subtract 7 is 14. That gives me that y is equal to 7. And then I can substitute that back into one of my equations. I'm going to use this one since it's already written out. So I get x minus 7 equals 7, in which case add 7 to both sides. I get x equals 14. There's my two numbers that have a sum, so when I add them up I get 21, and a difference of 7, so when I subtract them I get 7. Another two, same idea. The sum of the two numbers is 73, so x plus y equals 73. Difference is 11, so x minus y equals 11. And you've got a straightforward question. Subtract the x terms. Y minus minus y means 2y, and 73 minus 11 is 62. So y equals 31. And then again, you can pick any one of your equations. I'm going to pick the top one. So I get x plus 31 equals 73. If I subtract 31 from both sides, I get x equals 42. And that's it. I've got two numbers that when I add them together gives me 73, and the difference between them is 11. So what you've got is a set of questions to have a go at along similar sort of lines. I'm just going to give a couple of hints just in case. Remember, these two lines means that they're the same length. So I know this one is also 2x plus y. It tells you the perimeter is 365. So this one plus this one plus this one is 365. And remember what I said about angles in a triangle. This is an isosceles triangle. So this one is x. I know that if I add up the angles in a triangle, I get 180. So I can put these three equal to 180. Then you've got two equations you can solve. This one, similar to what we talked about last time, these two lines are the same length. So this one equals this one equals this one. And then you just rearrange all the x's and y's on one side and numbers on the other. You've got simultaneous equations. These three, very much the same idea to the first question that I put up that was up on last week's work. These ones should be slightly easier because they're equal to a number. So this one equals this one equals this. This one gets a little bit trickier because it's equal to a letter, which means it'll be a bit more similar to the one you had last week. And then you've got some worded problems to have a go at. Okay, any problems? I have done a Teams meeting today, but it will just be a kind of a drop-in session just because I am in school at the minute, which means I can't do it as a full live lesson, but I am there if you need some help on a certain question. Any problems, let me know.